So if you didn't miss my credentials, I'll sum it up for you. I'm a useful idiot.
Yeah.
I've been doing Go for about 5 years now. I got introduced to it on a team called Network Cloud, which is now defunct, although their products were open source. They're all now defunct too. Something that I'm going to actually demo later is built off of that, so it's not all for naught. But tonight is the idea of how we get started in Go. Going to do some basic stuff, and then we're going to do some not so basic stuff, and then by that time we're going to be about out of time, and I'll do the demo program that I put out here, and if you like what we did, we can hop off on that for the next time because there's plenty of topics to discuss on that. So I'm assuming my desktop is shared out?
Yeah, and then there we go.
Okay.
Now you're better there.
All right.
And I will copy out that comment there.
So if you haven't learned Go before, it's a C-style program. It's statically typed, compiled. And if you have trouble learning stuff, I got to tell you, I'm a terrible student. Even though I have multiple degrees, I don't know how I did that. I flunked out of calculus the first time I took it. I think if they taught calculus like they teach programming, I might have done better at it. But one of the important things that I always say before I teach a class like this is it's important to know how you learn. I learn by the fast dopamine feedback. You compile a program, it gives you a bad result, you know you did something wrong. You're playing in band, you play an F sharp in a key of B flat, you know you did something wrong. Not everything's like that, but programming's like that, and because I get that fast dopamine feedback, I can learn. So there's actually some documentation down here if you actually go out and read that. There's like 4 to 8 different ways people learn, and if you understand how you learn, picking up stuff becomes easier. And I didn't know that until I was halfway through my master's degree. But there you go. So I think the best thing that we can do right now is just write a hello world program, because why not? That's what we all do for the first time out. So we're going to do it in VI, because it's an homage to the first guy I worked with in Go. He did everything in VI. He had there are VI extensions for Go if you want to do that. More power to you. So let's make a directory here. And we're going to go into the directory.
I was going to ask too for anyone online, is that the font okay on the as it's coming through on the live stream? It looks a little small, but I mean, not horrible.
Read the blue, but that's
See if I can.
The color, yeah.
All right, let me see if I can change.
a little bit smaller.
Yeah.
Well, you got a response font is good.
Okay.
I doubt it.
Hey, Vinod. And also, by the way,
Is
I've
that
got
better?
this mic here for if you do have a question, maybe just give a heads up and then we can come out there, because otherwise, yeah, they don't hear it on the live stream.
So the first thing we'll do is a go mod and init. And that's so that you don't have to do any special path parameters or anything like that to get it to compile. So we're going to do go mod init stl go /hello. And so what that will do is create a go mod file. And if we take a look at that, it's going to say we're running Go. Basically, it's the module we're running and what version of Go we're using. I think there's a later version of Go out now, but this is what I have on my laptop. So next thing we're going to do is we're going to VI a file. We'll just call it hello.go. And package is up top, so we're going to do package main, because we're going to run this as a main program. We're going to import format, because we're going to do a format print line. And then we're going to create a function, main. And if I accidentally slip into Python, I apologize. I'll try to keep it to go tonight. It happens from time to time. So, and then we're going to do format.print line, hello stl go. And then, unlike other C-style programs, there is no terminating character. It's just end of line. There is no semicolon or anything like that. So let's write quit out of this. We'll do a go run hello. Oops. There we go. No? Command line arguments? What did I do?
Capital P on print line.
Thank you. Very good. And this is why we use IDEs.
For what it's worth, I hate this little feature of Go, honestly.
Yeah.
I'm totally with you.
All right, so
Well,
so we just ran.
okay, let's not go crazy. Right?
Eventually, we just ran our first Hello World program. Now you can go put Go on your resume and get paid millions of dollars. So, well, let's compile it to an actual binary now. So Go build hello Go. So what we should have is we have a hello file here, and it's going to be a binary. If I can spell it right. Yep. So it is an executable binary, and we can whack that hello. And there we go. So we just wrote a program, we compiled it to a binary, and we executed it. So that's one of the fantastic things about Go is you can do that, and you can transport it anywhere. I'm running Ubuntu 22.04 at the moment, so this would run on just about any Linux that's compatible. But as we all see that we're probably not going to do most of this in VI because of reasons. So this is VS Code, and it's what I use. There are others out there. There's a JetBrains version of it that some people like, but JetBrains is a cost thing. I'm a cheap bastard, so I use VS Code. VS Code isn't perfect. It's based on Electron. Electron, I think, is based on Chromium. Somebody might correct me if I'm wrong on that, but it's essentially a fancy browser. And you can get plugins for it. And to do Go development in VS Code, you need to have a couple in here. So I've got Code Spell Checker because I am the world's worst speller. Go, Makefile, which we're not going to cover make tonight, and some Markdown stuff. So when you get this here, you can actually write Go programs in VS Code. So I have shared out that the Git repository for this thing, just made it public this afternoon. So if you want to go out here and look at this stuff, all of the stuff we're going over tonight is out here. Specifically with the examples, we're going to walk through some of the basic stuff around typings, and maybe we'll get through files in JSON, and to logging and maps and slices and stuff like that, with about enough time to run the sample program later. Because I want to talk about WebSockets. I love talking about WebSockets. Everybody's probably tired of hearing me talk about WebSockets, but I'm going to talk about WebSockets, damn it. So the first thing we'll probably do is take a look at primitives. And this is already written out. If you want me to program it live, we could do that, but we're probably just going to wind up walking through some code and start talking about a few things. Like we have up here a function for Boolean types. So we have true, false, and we have pointers. So everything can become almost everything can become a pointer in Go, which is great until you dereference a pointer. So what do you mean by that? Well, let's go here and create an error function where we're dereferencing this pointer. So I'm going to come here and I'm going to create a TP2, and we'll just call it true. And so how to set a variable, you have to do the colon equals to set a variable, and that is going to be of type true there. So you don't have to, like Java, say string protected final blah 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 blah. It's just there as that type. You can set vars as a specific type, but for this particular example, we're not. So I'm going to create a pointer to that. TP2 point, and I'm going to assign it the value of TP2. Okay, so now that I've done that, I am going to print out that line. Format that print line. There we go. IntelliSense is a lovely thing sometimes. And I'm going to dereference it, TP2 point. And I'm sorry, I am trying to create an error, but I'm doing it incorrectly. There we go. This needs to be nil. And that's probably the wrong thing because it's not going to let me compile that, so I need to make it var TP2 and we'll make it a Boolean pointer. So now when we run this program, that's going to crash out because it's going to say you're dereferencing a nil pointer, and it's going to panic. So let's try to run this guy. Yep. Hide. Thank you. Go run examples, primitives, and primitives example.go. So, bango, panic. So that's some things that people will say when you first get into Go, and I was one of those people that said, why isn't there a try catch? Because that you could do that. The problem is, if you read the Go founders, is that the right word? Or primary developers, why they don't have a try catch functionality into here is because it forces you to deal with the errors where the errors exist. So in Java, Python, JavaScript, you can bubble up the errors and have a general catch. Yes, sir?
Kind of tangent, where are the where the colon equals and percent sign coming from? Because that's actually an auto hotkey, and I was wondering who decided to combine that style of syntax in auto hotkey with basic or Ruby or whatever else auto hotkey has gone on.
I honestly have no idea, unfortunately. Anybody else got that question, or about how that syntax came about?
I heard colon equals, I wasn't sure the context, Lawrence.
I don't think the colon equals and percent sign originated with Go. To which language Go inherited those from?
Well,
The first language that I know that used colon equals is Pascal.
and the formatting is, I think that's a C style formatting or C++
back to C.
style. Yeah.
I was gonna say, I kind of remember it from PLSQL as well.
Yeah.
So,
Colon equals, yeah, you probably,
yeah, yeah.
and maybe PL1. How do you say that?
It's kind of a mathematical construct when they were trying to do mathematical type
Yeah.
languages type thing, APL maybe.
I don't know.
So,
Strange symbols in APL.
great question, by the way. One I don't know the answer to truly, but so we just blew up our program with a panic, and we want to not panic, so we have to check for nil whenever we want to run a dereference. So if TP2PT not equal to nil, then we can dereference it. Whoops. All right, let's see if we can save this guy off, rerun him. This will have normal output now. So this one has all the primitive examples. I'm assuming everybody knows pretty much what we talk about with coding primitives, and we can probably skip ahead to something a little more interesting. Okay. Slices and maps. There are some interesting nomenclature for Go that isn't, at least to my knowledge, used in other languages. Like slices, I was unfamiliar with. But an array is a slice. So we can create an array, we can populate an array, we can do it all in one line. And then we can have an array of pointers, you can do whatever you want with it, you can iterate through the arrays. So to iterate through arrays, we have ranges, and it's the same thing with key value pairs. I believe you have, you do a range over a map. And it's pretty much the same thing for a lot of stuff with Go. You range over the stuff you're interested in, and you get the specific value you want. So for example, up here, we have ranges over here, and if you are trying to get something outside of the boundaries of the slice, you are going to kernel panic, or not, I'm sorry, panic again, and your program's going to crash out. So when you're calling specific indexes, you need to check and make sure that that index exists before you call it out, or you're going to blow it up. And again, this is pretty standard stuff, and it's, again, if you're familiar with programming, you've done it in Python, you've done it in Perl, you've done it in just about anything. Maps and arrays are fairly standard. So Anybody cool with that, or shall we move on to what I consider slightly more interesting, which is files, because I get to talk about gzip. And because if you're going to write a file, you might as well compress it. Files are the same way. We are able to create a temp directory here. We're able to join the path of that temp directory to a file name, and then we're able to write some stuff out here. So let's actually just go ahead and run this program. So we created a couple of things here, and we wrote some stuff to text. So temp stl go, created a temp directory, and oops, I need to see if I can copy that. And there we go. So it created, wrote it on the disk, did a timestamp on there. Files are specific in how you have to defer closing of them. So on read simple, did I defer close on that? Ooh, I probably didn't do that. That's unfortunate. So I need to go back and correct these examples because you're supposed to defer close on some of these things. So it's reading files, it's reading the output of them, and it's creating gzip files. That's the other part of this. So if you're going to write a file, write a gzip file. And if we take a look at the difference between the two, and it's not going to be significant in a small text like this, but if we, oops, all right. And that's got an extra tilde at the end. Okay, so that's a pretty small file. And this other one that is a gzip file is going to be also pretty small. But when you start talking about large swaths of data, I for a while there was running a web stream analysis thing that was doing 150,000 observations a minute. So that is roughly 1 billion observations a week. And you start adding that up on disk, it starts becoming terabytes of uncompressed JSON. You compress it, it becomes gigabytes of uncompressed JSON. So gzip is your friend when it comes to large data, at least in my case. Again, this is probably not significantly interesting, but the difference here is, yeah, minuscule. Actually, the gzip file is bigger.
I hate when that happens.
All right. But if you're not familiar with how to look at it on disk, zcat, you can use Cygwin if you're on Windows. I think Windows System Linux, WSL also has zcat in it. Don't quote me on that if it doesn't. But zcat will allow you to look at compressed files. And here's the defer close. So this is the, when you're writing it, you have to defer the close of the file handlers and defer the close of the gzip writers and defer the buffer flush. So defer in Go syntax is when the thing is basically out of scope, then handle this action. So I have a logger that I will show later that you defer the log timer, and it will time how long your function takes to execute. And I find that, again, sometimes interesting in large scale stuff because you're executing stuff, you don't know where your biggest time spend is, and if you put a timer on each one of these functions, you can go, oh, I'm spending the most time in this one, and you can go fiddle fart with it. So, but files, again, pretty standard. JSON gets a little bit more interesting because you can have basic JSON without any structure to it. You can create a map interface and assign values to it, and then marshal it out to JSON. You can also unmarshal it to, did I get that wrong? Backwards. I sometimes get that backwards. Marshal and unmarshal, I usually get backwards. And then you can unmarshal it back out to a map interface, or you can do it to a struct. And structs have these hints in here where you can say what your variables are going to be named in the JSON. And this example does both ways. It also shows you how to iterate through JSON maps JSON structures and maps. But when I bring it into Go, I usually turn it into a structure and care about the stuff that I want, although you can do it both ways. Getting stuff out of an untyped map and map string interface becomes a little bit like this guy, which is a map string any. It gets a little clunky because you have to start testing each thing. So it's like, does this thing exist? Is this thing a nil? Can I get this thing out of here? And then it becomes slightly harder to work with. So let's see, like scan JSON goes through and it ranges over a map string interface. And so it tests, is this an interface? Is this a map string interface? Is this a slice interface? Or is it a string key value pair? If it is, do something with it. And that becomes interesting when you start doing configurations, because if you want to obfuscate stuff on disk that are like passwords or secret keys or stuff like that, and you have a massive JSON and you want to go through, but you only want to look for specific stuff, this is kind of an interesting way to do that. And actually, the sample program does that, and we'll get into that in a little bit. But we'll go ahead and run this one because I also want to talk a little bit about JQ. If you're not hip to JQ, JQ is pretty cool.
I thought with Go you can set up your structures so that they map the JSON directly.
Yes,
kind of.
and this one does have that.
Okay, that's how I've used it before.
Yeah. So I have it both ways in this example.
Okay, great.
So it's one way is I guess untyped, more or less.
Yeah, so you don't really know what you're getting.
Yes.
You walk your way through it instead of getting something that you know that
Yeah.
what you're supposed to get in it.
And unfortunately, in the world I live, bad JSON data is a way of life. All right. So we're going to run this example in jsonexamples.go, and it's the same thing. We're going to create some stuff. We're going to write some stuff to disk. And like I said earlier, if you're going to write to disk, write to a compressed file. So we have both an uncompressed and a compressed JSON structure out here, and I think, at least I hope I did that. Yep, here it is. We're going to zcat this guy. I got to copy him. This is not my normal laptop. I threw Ubuntu on this, and copy-paste functions aren't exactly the same. I haven't figured out how to overwrite those hotkeys yet. All right, so we're going to zcat this guy. And so this text file was written to, was that the wrong one? Huh. Well, let's try this guy then. Struct-based JSON. There we go. All right, so that is a unprettified version of JSON. So if you haven't been hip to JQ, pipe that thing to JQ, and you're going to get let me install JQ, and then we can get hip to JQ. This is why you run through your presentation before you do your presentation.
Yeah, JQ is definitely a cool little utility. And there's even YQ for those YAML jockeys out here. So, yeah.
Which questions its own existence in its name.
Exactly.
So as I was saying, if you were hip to JQ, that prettified the version, prettied the JSON. But let's say if you want to get something out of it, you can get .file date, and it'll get the actual value for that. Super useful. The other thing about that, you'll notice the file date is in epoch milliseconds, not ISO 8601. I will do a whole rant on that, but
Yeah.
I will ignore that tonight. If you're transferring data, please, 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 please do it in epoch nanoseconds.
Yeah.
If you
I
need to have
remember
it-
1709167031086.
If you need to have it in human readable, do it next to it. Actually, I actually do have that here. I have it in ISO 8601 next to it. Again, I could go off on that for hours. So that's JSON. Is that pretty good? Pretty clear? Questions, comments, insults? No, okay. Let's see, what time we got? We got about another 10, 15 minutes here, and then maybe not even. And logging or go routines?
Go routines.
Go routines, okay. All right, so one of the things I love about Go is the ability to split stuff off and do parallel things. So this particular example has two versions of it. We have one without a wait and one with a wait. So there are reasons why you want to do both. If you have a long-running program, you can do stuff without a wait if you don't care what the output is. We have one with a wait group, and that's because you need it to finish before you exit the program. So we're gonna run this guy without the wait first, and it's going to exit prior to the thing being done. So oops, no, we're not gonna do that one yet. Man, that's a muscle memory right there. All right, so this thing's gonna do something, and did I do it? Yeah, that's weird. Did I not save that guy off? I did not save that guy off. All right, so like I was saying, we're gonna do this without the wait, and it's just gonna exit. So it didn't finish the thing that we wanted. And what the thing we're doing is we're just kicking off a basic random wait. So it's gonna wait a specific set of time and then kick out a message. And then the other one, the run with the wait, will do the same thing, except it's got a wait group with it, so it waits for all of those things to finish up, before it actually kicks out of the method. So that's the difference here. So if we comment this guy out and uncomment this guy and save it this time, this one will run until it's completed, where the other one just exited shortly after kicking off the go routines. So, and that's how you basically multi-core, multi-thread Go. You just kick something out, and that's fantastic, at least in my opinion, and one of the reasons why I'm sticking with Go with any large project I have at this point. So, questions about Go routines? Yes, sir.
I heard someone say that what makes Go routines not coroutines is that they are implicitly managed, not explicitly managed. So could you explain what that means?
Well, I can assume from the context of the question that we have, you're giving the management up to the compiler at that point. You're not, say for example, running a thread pool in Python or an executor service in Java. In those cases, you create a thing and you shove threads in there or execution tasks into there, and you let that do it, and you put a cap on that. And actually, I have a cap on some of this stuff where you don't want to consume an entire CPU with it, or the entire system, and you can. I've done that. So you're either giving it up to the compiler, which will then manage it for you, or you're going to have to set hard limits on it yourself. That's the difference between explicit and implicit management of that. From my trivial understanding, and please, if anybody here knows better, correct me. Does that make sense?
An abstract.
Okay. So
I mean, it's like garbage collection. Some languages do it more manually, others do it more automatically.
Yeah.
It's kind of like a spectrum, and Go seems to be somewhere in like the local maxima and that spectrum of what features do you want in thread management. And I don't know, because I haven't really used Go.
Yeah, I don't have a good example of that tonight, but you can put you can either put a channel or a limit on a wait group. And I think I did that with the channel, where you set a specific number of slots open. And so a channel has a maximum length. And so you have 100 tasks, and you try to execute all of those at once. But the channel is going to block it and say, I can only let 6 in at a time. So as that channel starts running down, the next one goes in until that stack finally empties out. So there are limits that you can do within Go. And again, I'm apologizing, I don't have a good example of that tonight. But it's more of a management strategy of how do I not burn down this system while I'm doing the thing, than it is, okay, that can go over the wall and just do its thing. Still a little,
I guess I'll start programming.
that is the best answer of anything tonight. Yes, just, and like I was saying earlier, I'm a terrible student. So talking about this stuff in the abstract, I'd sit out there and go, and then I would go home and completely forget about it. The way that I retain knowledge is I have to do it. And so if these examples out here in the GitHub repository aren't good enough, find me, send me an email, say, hey, how do you do this? And I'm happy to work with anybody on this. So, yes, sir.
I mean, it looks to me, correct me if I'm wrong here, that the wait group is really a count down latch, right? If that's another name for that, where basically you say, and you can set a size for it, like you said, you can set a cap.
Yep.
And then as you add things to it, when they get done, they say, I'm done, that counts down, and then you're done just as when it hits 0, then I release, right?
Yes.
So to me, the really interesting thing potentially in that whole example is line 51, I think it is, where it says go func.
Yeah, and this is,
Correct me if I'm wrong, is what that doing basically saying, here's a function, I want you to run this asynchronously, and that's all you have to say.
yeah.
Yep.
So that's the more interesting thing of what that demonstration is actually for me, is to say this is how simple it is to run something on another thread.
Right.
Yeah, you don't have to say thread equals thing thread dot start, or thread executor dot submit. Here's a thing, blah 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 blah.
The syntax is much cleaner because it's meant for that. Okay.
And that's really why I believe Go is at least in my non-humble opinion, is one of the best modern languages that we have, because everything else has its roots, 30 years ago, and this is a lot more modern in its syntax.
And has been created with concurrency in mind and all that, so.
I could argue that solving every problem with concurrency is like solving every problem with recursion.
Yeah.
Well, to first understand recursion, you have to understand recursion.
That's not where you use for first.
Yeah.
So I've got a real good example. I was running an old copy of QuickBooks Desktop on my laptop, and it was going kind of slow. So I opened my task manager and start looking at the individual logical processors. Sure, one logical processor is 100%. Everybody else is just sitting down here around
Waiting,
0, or 2% or whatever. So I said, yeah, this is an old program. It's single-threaded, it's not going to do anything unless, I start doing something else, because it's maxed out.
Yeah. And I mean, there's definitely horror stories too, though, about people going crazy with channels and just, really overusing the function just because it's there, thinking that, because the language allows it, so we should be using that. And it's just like, with anything, right? Moderation. It's use it when it makes sense.
Yeah, the common mantra of mine when I review code is more threads doesn't mean faster.
Right. Yep.
It just means more things that you're trying to do at the same time.
Yeah.
And it depends on the task. If you can take a thing and break it down into small individual units and kick all of those individual units off at the same time and you don't care, perfect. If they require each other, then it's a little harder.
Or if you exceed the capacity of your hardware.
Yeah.
Yeah.
running 1,000 threads on a 2-core CPU.
Well, I've got some Dell 2950s I'm still doing that on, yeah.
You know, unless they're I/O blocked, if they're CPU intensive, then you're not really buying anything. Then they just compete for each other, and ultimately the mechanics overhead around swapping threads, context, obliviates any results that you could have gotten. So I mean, I like the fact that it's simple, and I would say it would make it much easier to do that kind of thing, and so that's a good thing. But again, I'm concerned about how often you reach for something like that to solve a problem when that really isn't the solution.
Right.
Just because it's so easy.
Yeah.
I'll give you a good example that reinforces what you just said. There's a vendor out there, I probably shouldn't give them bad press, so I'm just going to omit their name. They have an API which we are a client of, and actually the project I'm doing at work is a proxy for their stuff because you get 429 errors from them because you've made too many requests. Really? And well, okay, I work for a very large company and we're making a lot of requests, but that's besides the point. The thing is, I have to throttle the number of requests that come through the system to do that. So I wrote a proxy in Go to do that because I can take and queue that stuff up and then I can slowly trickle it out. Unfortunately, I have 3 processes running, and so each one of them are trying to make requests at the same time, and if I don't have it perfectly synchronized, I can get nothing but 429 errors from them. So I have to throttle them all back. And I think they have a maximum of like 4 connections a second, which in this day and age is ridiculous. But anyway.
I can do that from JavaScript.
I know. Apache Balancer. So we'll talk about logging real quick. This was my one claim to fame when I was still working on the airship project. I actually fixed their logging for them because they were doing a terrible job of it. They were using something called Stackalytics. So it incentivized employees to go out and reject commits. Hey, you have an extra new line here. Okay, I'm sorry. I'll fix that. And please approve my commit. Nothing. But that was one of the 2 commits that I got through on that team, was their logging. So this is a bit of an extension to the log. Well, it's not really an extension to the log. It's sort of an enhancement to the log of Go. Go has a standard logging library, perfectly fine, but I want to see more stuff. I want to see the line number. I want to see the package. I want to see some other stuff on there. So that's what this does. And it's actually in the main part of the program. It's not in the examples. So if we want to take a look at that real quick. Oh, come on now. Cheap laptop doesn't like me today. But it's really just, like I said, it's a enhancement of the default log. So it creates a more verbose output. And I have overwritten all of the various functions here. We have debug, debug F, info, yada, yada, yada. And then it goes all the way down here where it has a write mutex, and then it puts out the output. So it does, and that output also has to figure out who's calling it and how far back in the stack am I being called from, and write it out appropriately. So let's go run that example real quick, and then we're going to move on. I believe we're getting to the top of the hour into the little stupid program I wrote for tonight. Well, the bigger stupid program I wrote for tonight.
Well, while you're doing that, I'll just plug myself and say I know a little bit about this because my only maybe professional claim to fame is I am the original author of the Log4j pattern layout.
I have used that layout quite a bit. So thank you. All right. So this is what I like to see in a logging output. Whether or not you do is it looks a lot like Log4j, at least in my versions of it. We have a date, we have a timestamp, we have the overarching package it came from, the actual package itself, and the line number in which it was called from. So to me, it was easier to debug this stuff when I was working in the airship project because they just basically had a log line, and you had to to do a search on the entire code base to figure out where that log came from. And I've basically just used that same logic forward in all of my projects at this point. So, since we're getting close to the top of the hour, I wrote a little project called Grow with STLGo. It's, and we'll briefly walk through the code base and very briefly walk through the code base, and we'll do a demo of it. So we have, it's using Cobra for command line options. I'm sorry I didn't cover that tonight. If we can get to that next time, hopefully, and takes command line arguments, executes a web service. The web service has both WebSocket and REST APIs in it, and it also serves up static HTML. The static HTML, I do have some JavaScript in here. The JavaScripts are modules, again with a logger here. But it is not React, it's not Angular, it's not Vue, it's not, what's HTMX is the new one, I think. It's standard stuff. And the reason why I did that is because I think it's a fundamental thing to learning is to learn it without packages. If you can do it with the base programming language, you can do it with anything. If you learn it with a package and you rely on the package, and that package decides to go unsupported, well, then you got to relearn it anyway. So that's my treatise on that. But it's a, you all remember WebSphere?
Oh, yeah.
There was it the pet store or the plant store was the default application in WebSphere 3.0 where you could demonstrate the cluster, and I think WebSphere 3.0 was a terrible name because that was the first iteration of it, but besides the point. So this is kind of an homage to that. So let's go ahead and kick this guy off here. Actually, I don't want to do it here. I want to do this command line because I want to show that this thing will run just off of GitHub. So I'm going to create, I'm going to get rid of that tempter, make dir temp. And do I still have git clone in my, no, that's not it. All right, well, where is the website? Here it is. All right. All right. Oh, come on. There we go. All right, so we're going to clone this down. New directory, straight clone. And then just going to run a make. And this is going to do the Node.js dependencies because I'm using font awesome and a couple other stuff in there. And you don't want to kick that into your repository, so why not just use somebody else's repository for that? It's going to build the binary once it gets there. It's going to build binary.
Thought this was faster.
Well, that was Node. That was Node. Yeah. All right, so we're done, and oops, and we have the file in the bin directory. So bin grow, and I'm going to kick a -h to it, and that's going to show this is Cobra. So if you're unfamiliar with Cobra for command line uses, it allows you to do your command line args, and it's flipping awesome. Mm-hmm. If you all got something out of tonight and you want me to come back in a couple of months or weeks, we could go over some of this stuff. So I'm going to kick the log level up to 6 because that's trace, and we're going to kick this guy off. And what you're going to see is it built an embedded database. It's using SQLite. That SQLite is encrypted. It is creating users with passwords. Those passwords are then hashed and encrypted on disk. So even if you decrypted them, they are hashed. And then it is populating, it is creating and signing an SSL key pair. because there is no reason to not do anything over HTTPS anymore. And then it's also populating the database with the default stuff. So now that this thing is up and going, I'm going to grab a password here. And if I can remember what the correct key sequence is for Ubuntu, we'll go to localhost on 10.4.4.3. This again is just a basic Bootstrap 5 website, nothing fancy. And we'll do login. Oh, come on now. Click. What's going on? All right, let's try that again. That's why. Okay. Because it's, you know, it's a self-signed.
Signed, yeah.
Self-signed storage. Yeah. All right, let's try that again. There we go.
Yeah.
So we can create another user here because you see last login. So let's create a test user. And it's going to go ahead and copy that out to my keyboard because I ain't going to let you just create any normal password. So let's go ahead and log that guy in. What did I call him? Test? Test. All right. And this is test. All right. And you'll notice there isn't a user admin thing up here. So again, it's an admin function. So he's not an admin, shouldn't be able to see it. But this is the plant store. So we can go in here and we can go, okay, I want to grow dill this year, so I need to purchase a couple of things. And let's go over here as a different host. You see packets available. So if I purchase that here, I see 99 here. Let's purchase 10 here. You see 89 here, you see 89 here. That's all over WebSockets. The pagelets over WebSocket, the user interactions over WebSocket. The only thing in this page that's not over WebSocket are the images. And you could put the images over WebSocket, I just didn't have time to do that. So. But that's the stupid little program that I wrote for this. And I could show you how to interact with this with curl and Postman if you want, or we could discuss here and move on, or we're at the top of the hour and eventually my monotonous voice gets tired of, I get tired of listening to me. I can't imagine anybody else is still awake. So questions, comments? You want to see anything in particular? Discuss anything in particular?
This is in JavaScript and Go?
This website is basically it's HTML and JavaScript. I'm injecting something I call a pagelet, whether or not that's the right terminology. It's a single user page. I'm sorry. Single page
application.
Yes. So this is just a container, and I'm injecting the pagelets into it, and then I'm formatting data coming back from the WebSocket. So if we take a look at this guy, the pagelets are, where are the pagelets? The pagelets are here. Just little stupid bits of HTML. Like, that's the seed page. It's just, that's it. And I need to clean up this particular thing because of this thing. I can do that as a for loop, but I was running out of time to get this ready for the demo. But this is where it all comes from. And like on the page startup, you see send message to the WebSocket. In this case, it's send this.type, which is seeds. Components get inventory and subcomponents get inventory. So if you think about this, and I think about this in terms of biology, so you have a genus, a species, and a cultivar. You can also think about it as a URI. So that could be the root of the URI, that could be the next part of it, so on and so forth. There is no real standards to WebSockets. WebSockets have an on-open, on-message, on-error, and on-close, and everything else is whatever you make of it out of JSON. So you have to handle that on the back end, and I use something called a function map. Since we're talking about that, let's dive into that a little bit. So on my well, actually, let's talk about the server part of that first. So I have a couple of handlers down here. We have a web server mutex. The WebSocket is specifically on that handle function. And what I want to point out is when you're writing public APIs, damn it, put a version number in your URI. Because stuff changes and you want to tell people that it changes. So we have the web server mutex there, or I'm sorry, WebSocket mutex. The WebSocket's handled off of that. And so the WebSocket goes onto the on-open here, and that initializes a session, sends back a session ID to the user, and then the user is, at that point, has 30 seconds to respond with, this is my credential. Because it's using, actually, let's look at Postman real quick. So if you haven't used Postman for WebSockets, you can do that. So, and I made notes earlier so it'd be easier. We can do this with curl and we can do this with WebSockets, but you can't do WebSockets with curl. So you have connect, and the connect has this message here, which is real basic. We have a session ID and so on and so forth. So I need to drop that session ID in here, and I need to grab the password for user, which is way, oh, nope, that's in the other thing. That's probably going to time out before I get there. So user's here. So let me grab a password for user. And then, so we have, again, this is what I'm calling sort of that binomial naming pattern. So you have a component of, you have a type of the WebSocket client, which is, in this case, the top level thing that's going to handle and cipher all this stuff down. And then later you see seeds. And seeds is registered to that function map as I handle this type. So when it comes through, it looks up, okay, it's not a client, what else am I? It's a seed, okay, handle this function. And we'll go back over here to the WebSocket itself. And it goes through the authentication stuff. It creates a JSON web token, validates JSON web token, and eventually kicks you down to the handle, the request.
Yeah.
And so the handle request goes through the function map. And the function map says, can I handle this? And the function map is at the top level in this case, which would be a type, and it'd either be WebSocket client or seeds in this case. And a function map is a map of strings of type function, which is, again, I think it's fantastic. Because you get circular references here. Because I can't have WebSocket include another package to include WebSocket. So on the initialization, we'll go look at seeds, for example. I call out, and that's probably way at the top. Where's the init function? Here's the init. No, where's the init? Here's the init function. So I call out to the web service, append me to the function map. And I also do that for the REST function map. It's the same thing. I append that to the function map, so when it comes through, it can route the traffic to here. And when you handle the WebSocket request in this case, we go through a switch and say, am I getting details? Am I purchasing seeds? Am I getting the entire inventory? And so that's kind of how I'm routing stuff. Like I said, if we take a look at my notes here, we have top level type. Type would be seeds. In this case, this is seeds. Component, that's a secondary type. And where are we? Secondary type would be component, get inventory. And then if we take a look at something like this, subcomponent down here is a different thing. We're getting something of a specific thing at that point, which is you can add additional data. And in this case, it's an ID of a seed packet at that point. So where was I going with this? So that was to say that's how I'm interacting with this. Is that the right way or the wrong way? It's a way. You know, when I've seen other WebSockets, I've not seen this type of structure. It's all just sort of, you go to this endpoint and you send data and we send it back and forth. I like this because it allows me to have one entry into this and you could just send whatever you want through it and we handle it for you. You don't have to have different endpoints for every one of your calls. Again, right or wrong, I don't know.
And so you're going to one endpoint, one API call, and then the JSON input is determining where it goes to get the
Yes. So instead of a URI for REST, I split the URI into basically 3 parts in the JSON. So let's see if we can get that to work over Postman.
And this is all out on the GitHub.
It is, yes, sir. All right, so if we connect and I did this correctly, can I, yep, I got an auth complete and we have our token here, which is a JSON web token. Grab that guy, and then I have to go shaboink here. Oh, I just did a copy. Damn it, gonna time out again. All right, let's try that again. Control C, Control Shift V. Did that, I don't know, did that override? It did not. All right, just not having a good time with this tonight. Control Shift C maybe? Okay, there it goes.
Some way
That
you get
extraneous
post-
comma at the end, I'm not sure it'll matter or not.
Yeah, that will matter, actually, it'll kick it out. And did we time out yet? I need to change that timeout.
I'm good at finding semicolons too.
Okay, yeah, I was disconnected before, so it got it denied because it sent a request to the WebSocket and then said, whatever. All right, so let's try that again. This is why you do it with a client, not with Postman.
Indentation also.
Can't you get Postman to continue your session type thing?
This is ending the session. I have a 30-second timeout on that.
Oh, okay.
So if you don't get this done before then, it's going to say no. There we go. Let's try that now. All right. Nope, disconnected. So I did something, it doesn't like that. But anyway, so it was an auth denied. Why was that an auth denied? It did something it didn't like, and it just kicks you out. So that's the other nice thing about WebSockets is if you're not timed out here, oh, it just timed out. So it has a 10-minute timeout on that session too. So it'll kick you out when you're idle for 10 minutes. So it just proved that for me. Anyway, I could talk about WebSockets for a long time. But again, we're past the top of the hour. You got a question?
Well, I kind of do, but it probably is too long for now. I'm still learning some of the syntax. I have 12 years in C, but it's a while ago, so I'm still having to learn how to reinterpret pointers to pointers to pointers. And so I'm assuming that the asterisk is either declaring a pointer type or dereferencing a pointer type.
It is
And
dereferenced.
is taking the address of something, right?
Yes. Yes.
Okay, so according to that, you're passing like a instance of a struct, or actually a pointer to an instance of a struct
Mhm.
to this function. And I have not gotten this place yet, but I understand you can attach functions to structs,
Yes.
which is the closest thing those got to object orientation.
Let's see if I have one of that here. It's called a receiver function, I
Yeah.
believe,
Yeah.
is, do I have a receiver function on this one? I have a receiver function on this one. Where are my receiver functions? I have receiver functions in here somewhere.
And I'm looking for that. Is the syntax
Probably on the
for calling
handlers,
that
wouldn't it?
function then
Yeah, probably.
through the struct itself, the struct instance?
I'm sorry, could you repeat that, please?
So if I have an employee struct E, I've got an instance of it, so I've got like a pointer to E. Do I call E dot function just like I would have E dot
Yes.
primitive? And then it knows by reference that it's operating on that struct.
Correct.
Mhm.
Great, so if I were to take that,
Oh,
to
here
go
they
back to your example, on your server, maybe the one thing I would have thought of doing differently was to put the functions that are the receivers of those component types as functions on structs.
Mhm.
Because that way I could follow more of sort of the open close principle in developing this, where I wouldn't have to interrogate the components for its type and then do something based on that. I would say, this is your type, I call your receiver function, whatever it is to do the job.
Yeah.
And then if I had a new component that I define later, I don't change that switch statement. I just create the new thing and it works.
Mhm. And these are the receiver functions I have, and this one is for the embedded SQLite database. So, let's see. So I'm just calling SQLite dot, oops, get encryption keys there. So that's a receiver function for that, and
Okay, cool.
it's very cool, yes.
So at least some of what I know still applies.
All knowledge is good.
I mean, the creators of Go were C guys.
Oh, I know
so,
it, I know,
Yeah,
I've read it, yeah.
Yeah.
It seemed like they were hankering for the old days.
At least the good parts, right?
C++ stuff, so we're just gonna go back to the next thing closest to assembler language we can have. And throw in a few things that we think are cool, and call it something, you call it Go.
I think they got upset about compile times.
That's the story. The other story I've heard is that they found that C++ was too complicated for junior developers that were coming into Google. And so they had to create something simpler. Now, I'm thinking like, I remember some really god-awful code in C. I don't see how this is simpler.
Which language? Sorry, I was getting water.
Right, which one?
Which language?
C
Oh,
or Go? I was talking about Go.
Oh.
What they say they developed Go. And it was supposedly waiting for a compile chain to run. You know,
That's when they wrote it, yeah.
And I personally don't like C++ either. You know, my own reasons for that, we'll leave those on the table.
Is it operator overloading?
I said I was leaving it on the table.
I guess that'll do for tonight, unless
Awesome.
we have anything else to discuss. Oops.
If I can just throw in, maybe you could add this to the presentation later. I've actually been using a site called exorcism.com, and you guys might know that already.
Yes.
And I've been going through the Go trail there, and I'm picking up a lot along the way. Each one of those units are like 15 minutes
Yep.
tops. You know, so if you want to like learn something in 15 minutes and do that every day, you can learn Go in a month, right?
Yeah.
I'll add that to the repository as another place to learn,
Okay.
because I think there's several out here that are, go by example and some
Yeah,
other
let's
stuff.
look at those too.
Yeah, and exorcism is actually the kind of official method for learning Go now. There's a bit of a partnership there, so.
Would that just start with an X? I got some.
EX.
EX. Yeah.
Oh, it is? Oh,
Yeah.
maybe I misspelled it.
Yeah. Exorcism dot, I don't think it's an IO, I think it's
.com.
.com, yeah.
And the nice thing is they've got examples that demonstrate different parts of the language with the tutorial, and then they've written the tests already. So they give you a template for the code. Basically, all you have to do is fill it in using what you've learned in that particular section.
Yeah.
Org.
Is it org?
.org.
Okay. Yeah. But yeah,
Get something
Yeah.
married.
you never know, yeah. Awesome. No, that was great. Any other questions?
Yes, sir?
I know you can run VS Code because it's free, but do you know what about Golang makes it work fine?
That's the JetBrains version of
You
it.
know,
My previous team really liked that, but I was, purist isn't the word, curmudgeon maybe, but I like stuff that I can do that doesn't tie me into a license, that makes me repay it. So if when I left that team, and I was only on that team for 9 months, that's a whole other story I'll get into some other time. If I left that team and they weren't renewing my license, I would have to transition to something else anyway. Because I'm cheap and that is not an inexpensive license. So I'm sure it's great. PyCharms is also by JetBrains, and I get a free license for that. That's It doesn't do JavaScripty stuff well, and it doesn't even do Python that well, but I'm just used to it, so I keep using it.
yeah, I know personally I'm a big fan of Golang. I use that, and that's coming from a Java background too. I worked at a shop where we were all using IntelliJ, so JetBrains. So it's just like, yeah, it's kind of a crutch, so I'm used to using that. But yeah, so
Yeah, and
I did fork out the, $150 or whatever for a year license. Now, get your friends coming here, because then if we get enough people past this threshold for attendees for the meetup and that, JetBrains will give us sponsorship, and then we'll be able to raff off JetBrains licenses, you know, so.
Yeah, the Java user group used to always do
Yeah,
that.
yeah. That's why every once in a while I would go to the Java user group, and then I would win a license, and then I would use it for Golang, because it's good for any JetBrains product, so. So yeah, there's a possible thing, yeah, Python groups, join them if they're giving out JetBrains licenses, and the Java user group and that, yeah, you might be able to get yourself a Go IDE.
Did you have a question?
No, I was just gonna comment, like, the thing that made me, like, love, like, IntelliJ,
Yeah.
Ultimate, and, like, Golang, is, like, you can copy and paste, like, a JSON snippet into the IDE, and then it'll create struct automatically for you.
That's nice.
Like, you don't have to actually, like, type out.
Oh, wow, yeah, see, I haven't tried that. I mean, I know JetBrains has ridiculous numbers of little shortcuts and things that'll do for you. I've yeah, barely scratched the surface. Just,
Yeah, right-click refactor, and
yeah.
find something new every day.
yeah.
I tend for a kind of barbell approach, so I'll use like IntelliJ on like a heavy Java project, but I'm doing something lighter. If you're feeling brave, you can get Go support set up in NeoVim with the same debugger as you get in VS Code. Dell. You can get full Dell support set up pretty easily in NeoVim.
Why don't you like Emacs?
What's wrong with Vim?
Lisp is just too many parentheses for me, so
Lots of specific students.
too many parentheses.
The first guy I learned Go with had it all set up in Vim. It was,
Really?
Yeah.
I still have that squirreled away somewhere, but I've never used it.
That's awesome. That's awesome.
You guys actually just reminded me I have a personal JetBrains license I need to cancel before we use.
There is a Go wiki page that has a whole list of editors and IDEs for Go.
Yep.
Go.dev/wiki.
I will stick that on there too.
Awesome. All right, we don't have any questions from the online folks, so, yeah. All right, well, awesome. And then, yeah, so now I get to use this new fancy thing in this new software.